Hello, today I am going to discuss about the Allen Bradley RSLogix500 jump to label instructions. So let me create a new file. Click the file, click the new, then select any option here. Okay, make sure the driver is emulate 500, then click OK. Now let me create a few runs here. If you are not sure how to navigate around and create the new runs and the necessary instructions, please refer to my previous video. Okay, so I create a few runs here. Okay, then I will insert all the necessary instructions. Then insert the virtual output coil. Okay, then I will go to program control tab and I will insert jump to label here. Okay, let's say this is digital input column slot 0 slash bit 0. Okay, let's say I name it as switch 0, and this one, the address is digital output column slot 0 slash bit 0 or terminal point 0. So let me name it as lamp 0. Okay, let me copy the address. Alright, okay, this one I will name it as 1, then switch 1. This one I will name it as 2, then I put switch 2, then this one as bit number 3, bit 3, then switch 3. As for this output digital bit, I will change to bit 1 or terminal point 1. So this one should be my lamp 1, 2. So lamp 2. This one change to bit 3. So lamp 3. Okay. So this one, instead of using the digital input, I will use binary. So it's up to individual. Okay, so binary I type B stand for binary, which is the file type, then followed by 3. 3 is the file number. Okay, if you're not sure, you can refer to here. See, binary is B3 column. Okay, word 0. One word consists of 16 bits, so I will use a bit 0 here. Okay, so maybe I name it as activate jump to label. Okay, so this one is a jump to label instruction. I need to give an address. Okay, you double click, then you type Q. Q mean label. Okay, this label is inside the file 2. You can see file 2, or you can see here 2, file 2. So you should type file 2 column, then followed by any number you want. You can number 0, 1, 2, 3, and so on. I use the number 0. Okay, maybe I put jump to label. Okay, so I will put maybe one more here. I put the label here. Okay, then I select label. See, click the label and drag and let go. So this label should share the same address with the jump to label instruction. So I click the black highlight and I drag it until here, I let go. So both will share the same address, so that when the scanning come to this round, okay, then it will straight away jump to here and start to execute all the following programs. All right. Okay, so once done, verify by compile it. Okay, verify the file to make sure no error. If you see error, try to understand what's the error. Okay, the label must be the first instruction in the run. What it means by this? So you it means you have to put in front of this virtual switch, right? Okay, then we verify one more time. So no more error. Verify the project. Then we save the file. Okay, save into your computer hard disk. Let's say I will say this one, jump to label. Okay, save it. Then click here and download into the virtual PLC. Click yes. Then make sure to click here one more time to select run. Alright. Okay. Now what will happen is the computer will scan, the PLC will scan for run 0 to run 1, run 2, etc. Okay. So let's say you do not activate the jump to label instructions. Okay, you do not activate this binary virtual switcher. So this jump to label instruction will not be energized. So nothing will happen. Okay, so once you turn, once you trigger the bit here from normally open to close, the virtual power will flow through this rung and then will energize this virtual output coil. Similarly for this rung, and then you will continue execute the following program. However, if I trigger this binary virtual switch from normally open to close by clicking the bit toggling, the virtual power will flow through this run and energize this jump to label instructions. And then this will cause the scanning, the program will straight away jump to here. And then we'll start execute the program from this run onward. Alright, so let me do a test. Okay, so if I toggle this will be energized. Okay, of course. How about this? If I toggle bit, here will be energized. Of course, if I toggle here, here will be energized. Okay, let's say I normalize the virtual switch condition. Okay, and then I will toggle this binary bit so that it will be triggered from normally open to close. What will happen? Okay, now the virtual power will energize the jumps to label instruction, and it will jump to this label and start to execute all the instruction here and on and below. Okay, now what happen is if I toggle it, nothing will happen. If I toggle this one, also nothing will happen. Why? Because this jump to label instruction is energized. Thus, it will jump the execution from here straight away to this label and start the execution from this run onward. Alright? So I hope that you understand. So that's it. Thank you.